Hello everybody, and thanks for tuning in, wherever in the world you may be. My name is Jeremy Tatar, and I'm a doctoral student in music theory at Montreal's McGill University. In this presentation, I'll be examining Morton Feldman's rhythmic materials from a set theory perspective, and draw on various resources from this analytical toolkit to explore his piece For Christian Wolff. I hope that you enjoy, and don't forget to get in touch if you want to talk further about any of this. In the description of this video, you'll find links to both a brief handout and a script, so you can follow along with either of those if you so wish. Surveying the range of analytical challenges presented by the late music of Morton Feldman, Dora Hannanen argues that the main problem is not the sometimes gargantuan length of these pieces, which range from around 80 minutes to 6 hours, give or take some change. Rather, the real problem, she writes, is not quantitative but qualitative, not the duration or the number of notes, but the identification of salient features that support memory and conceptualization. In these pieces, the listener is faced with what Hannanen calls a superabundance of nuance that eludes conceptualization, as patterns of material are continually modified by minute adjustments of timbre, duration, and pitch. The opening of Feldman's 1986 piece For Christian Wolff is particularly illustrative of this process, where 3 pitches and 3 timbres, flute, piano, and celeste, weave amongst themselves in a flat landscape of triple P. Let's listen to the first few measures for now without a score. So, taking Hannanen's comments as my springboard, this presentation proposes an adaptation of beat class set theory to investigate Feldman's rhythmic language, an area which has thus far received scant attention in analytical studies of his music. I argue that this beat class set theory approach is helpful both for securing those elusive nuances described by Hannanen and for tracing their possible developments over the course of a piece. For purposes of time, I will be focusing solely on For Christian Wolff, though there are many shared characteristics between this work and others by Feldman from the 1980s. But first, what do I mean by beat class set theory? Simply speaking, I mean regular old set theory, except using attack points with respect to a downbeat in place of pitch classes with respect to C. We could begin by imagining a measure of 12/8, and assigning every 8th note an integer from 0 to 11, beginning from the downbeat. A beat class, then, is the metric location of this integer within a measure, in the same way that we understand pitch classes as occupying a position in the chromatic scale. A beat class set is a group of these metric locations within a segmentational unit. This rhythm, for example, gives us the beat class set 0, 5, 6, 8, since those are the integer positions where attacks fall. I mark this set with curly braces and indicate its more abstract set class in square brackets. We are then positioned to do the same kind of music theory that we are accustomed to in pitch space. This rhythm, 2, 7, 8, 10, for example, is T2 of the original pattern, while this one, 0, 4, 6, 7, relates to the second rhythm by I2. Music, of course, is written in meters other than 12/8, meaning that we often need to use modulo systems other than our familiar mod 12 arithmetic when dealing with beat class space. 2 aspects of this theory that I am leaving aside for today are questions of segmentation and the status of inversional equivalence, but I encourage you to ask about these in the question period, or, send me an email or something. Returning now to For Christian Wolff, Figure 1 annotates each of the opening 8 measures with its cumulative beat class set in curly braces, along with the set class of this rhythm in square brackets. In measure 1, for example, attacks at positions 1, 3, 5, and 6 reduce down to the set class 0135. Note that in these analyses I use the measure as a segmentational boundary, yielding a consistent Mod 9 beat class universe due to the 9/8 meter. Nota bene, because this will of course affect what our math looks like. Such a beat class set perspective allows us to describe, for example, that despite the differing surface rhythms of measures 4 and 5, attacks at 0, 3, 5, 6 versus 0, 3, 6, 8 respectively, they are connected by a shared rhythmic set class, O136, and related by T3. Let's listen once again to this section with the audio excerpt ending right in the middle of measure 6. The instrumental distribution of pitches in this example, where the flute oscillates between A-flat 4 and G-flat 5, with keyboards both on G5, remains unchanged for the first 50 measures, about 4 minutes in clock time. In measure 51, however, the flute breaks this stasis by shifting to G5 and A-flat 5, while the keyboards both move to F-sharp 5. Figure 2 shows this change in registration, which is accompanied by the first appearance of beat class set O124. Although the pitches G-flat, or F-sharp, G and A-flat still persist from the trichord established in the opening, after 50 measures the change of voicing here is almost seismic, and its coincidence with a previously unencountered rhythmic set class further articulates this moment of difference. Measure 52 also shares this new O124 set class, which is related to that of measure 51 by I5. Measure 54 likewise contains the first appearance of O134, elements that all work together in tandem to consolidate the newness of this musical moment. Let's listen to this excerpt beginning exactly where figure 2 picks up. Drawing now on a different analytical resource of set theory, this diagram offers an abstract map of voice leading for tetrachords in Mod 9 space. A line joining any two set classes in this graph means that they are related by some single stepwise displacement. To move from O123 to O124 is a displacement of one step, while to shift from an O123 to an O145 requires more voice leading work. With the aid of this map, we can further flesh out our story of For Christian Wolf's rhythmic development. After beginning with the set O135 in measure 1, we soon encounter sets O136, O146, and O246, which together form a relatively tight rhythmic network over the first 50 measures. The change of voicing at measure 51, however, brings with it the new set O124, which is significantly separated from the extant network. The markedness of this moment, which we just observed, is thus also accentuated by the differentness of its rhythm from anything that had come before it. Staying with this idea of voice leading space, examining the moment-to-moment progression of these beat class sets using the transformational voice leading technology of Joseph Strauss illuminates further aspects of the piece's rhythmic organization. In Strauss's terminology, a crisp transformation occurs when all voices move in the same amount, while a fuzzy transformation, marked by an asterisk, means that one or more voices deviate slightly from this amount. Strauss calls this deviation an offset, which appears beneath the transformation in brackets. Figure 3 presents the beat class sets of measures 1 to 8 from this voice leading perspective, where a fuzzy T0 with a small offset is the prevailing transformation between measures. If it helps, compare this against Figure 1, which you can find on the attached handout. And while, at first glance, a whole bunch of T0s might seem inconsequential, attending to their offsets reveals a certain progression. From measure 1 to measure 4, the earliest voice in the pattern, which is at the bottom of each rectangle, shifts twice from beat class 1 to 0, producing a total offset of -1 after 3 moves. Following a crisp T3 between measures 4 and 5, which we noted before, the earliest voice now wanders from beat class 0 to 2 in measure 7, and then back to 1 in measure 8, eventually producing an offset of +1. As these arrows indicate, a cumulative displacement of 1 beat class earlier in the first 4 measures, which results from the sum of the 3 offsets -1, 1, and -1, is counterbalanced by the shift 1 beat class later in the subsequent 4. This second phrase, from measures 5 to 8, could thus be understood as some form of compensation for the first. I wish to emphasize here that I am as interested in the ways that these individual motions trace a sort of journey with its own twists, turns, and switchbacks as I am in the ultimate destination that they reach. I hope that such an attitude might bring us closer to understanding the series of characteristic gestures, in David Lewin's words, that build up this excerpt, as well as how its rhythmic surface is shaped by a relatively restrained compositional palette. So, to summarize, despite an ongoing focus on aspects of temporality in Morton Feldman's music, the specifics of his rhythmic language remain underexplored. As I have argued in this video, interpreting his rhythms as beat class sets helps us track larger scale shifts and correspondences between musical events. Furthermore, tracking the voice leading between these rhythmic sets helps us better understand certain consistencies in transformation at a local scale. Ultimately, such a theoretical apparatus works toward overcoming what Hanneman calls the qualitative difficulty of his music that I referenced earlier. I hope that, in the rhythmic domain at least, Feldman's superabundance of nuance need no longer remain so elusive. Thank you so much for listening, and have a look at the handout attached for my bibliography. Big thanks to the Music Theory Society of the Mid-Atlantic and everyone else who helped make this research possible. Remember to send me an email, and I hope to see some of your faces sometime in the not too distant future. Bye for now.